has a derivative in it. That's our y primed. The goal is to get rid of it. So we change the y primed to dy dx. And then you want to get everything with an x in it on one side, everything with a y in it on the other side. So we're going to multiply the dx up. And then how do you get rid of the dy and the dx? You integrate it. You integrate both sides. What is the integral of y with respect to with respect to y?
1.
No, that's the derivative.
Oh.
Y squared over 2. You add 1 to the exponent and divide by it. So you get y squared over 2 is equal to the negative 8. Doesn't really matter. We can pull that out. What's the antiderivative of cosine x? Sine x. What do I tack on?
Chain rule. What?
Plus c. Constant.
Oh.
You're basically done. You can multiply the 2 up if you wanted, but
we have to isolate y though.
you want y by itself?
Yeah, I think he said.
Okay.
Most questions are gonna be like find the function, right?
Okay, so we multiply the 2 up and we get negative 16 sine x. What's 2 times c?
2c. Oh, you can leave it as c.
You just write it as c. 2 times a constant is some constant, right? And then if you wanted y, you would
Root.
And when you square root it, what do you have to remember?
You can't root negative. So you got to put 16 out.
Nope.
I feel like that's still valid.
I would just leave it as y squared, but
You can't root the negative.
I think that's better. Yeah, but sometimes sine is negative, so then you just have a domain restriction. That's all.
I just don't like that.
This is what I would have preferred, and then you could. That looks cleaner than some square root plus or minus, but whatever. The process is all that really matters here. How do you find c? What other information do you need to find c? You have to be given other information, right? So we can't find c in this case. All right.
If you are given y next,
you plug it in and you solve for c. All right.
That's a differential.
So this is called the general solution. Does he use those terms? General solution. And if you solve for c, it's called the particular solution. I think I mentioned that before to you. All right. You want one to do on your own?
Yes.
He's probably just going to do pretty straightforward ones like he did yesterday, right? Okay.
That online quiz.
Sorry?
Like any store with a jewelry store.
Oh, jewelry, yeah.
Yeah.
Well, they have like the super big ones. Like I was at the Costco's tire place.
There you go.
That's
There's your question.
That is we paid that off till you die.
Well, what's your first step here?
Your grandchildren would be paying that off.
Yeah, that's much.
There you go. Change your y primed. I'm going to pause this video. All right. Chapter 4. All right, your test next week is on chapter 4. So that is, let me just do a quick summary of chapter 4. It was basic integration, which I will go over. So that's like power rule. Did we call it the power rule?
Yeah.
Did we?
Yeah. I remember seeing that in my notes.
So that's like the integral of x to the n dx is equal to x to the n plus 1 over n plus 1. That type of integration, like the most basic kind. U substitution. We don't need to close our brackets.
Oh, that's a syntax error right there.
U substitution, but the basic kind of U substitution. So x root x squared plus 1. That type of u substitution. I'm going to go over these things. What else is in the chapter? 4.
Summation.
Summation rules, yes. And I'll do an example of summation rules.
Define integrals.
Oh, definite integrals, thank you.
Yeah.
6th time.
Is there anything else? I think that's pretty much it, isn't it?
Summation to infinity, which is a summation thing. But
Yeah, well, I'll do an example of the summation. Definite integrals. Remember, a definite integral is one that has numbers, right? That's a definite integral. You don't have to put plus c in there because you actually get an answer. I think that's pretty much it for chapter 4, isn't it?
it was actually a pretty easy year.
Yeah.
It was probably the easiest
All right.
one so far.
Well, so I'm have stuff I'm gonna post today in the chapter. Like I'll do it this block. Thank you very, very much. That was it. Okay.
And for
So definite integration is the first fundamental theorem,
There's also one more.
and then there's second fundamental.
And then there's using the right and left corners, right?
Yeah, I'm gonna do that that's the summation stuff. First fundamental theorem, which is the integral from a to b of f of x dx is equal to capital F of b minus capital F of a.
oh, that's what
That's first fundamental theorem. Second fundamental theorem, although I've heard them call it reversed in what they call first and second, doesn't really matter. The second,
Yeah, I do that with Newton's laws all the time.
fundamental theorem says that if you have f prime of x defined as 0 to
This one's
I'll put c for a constant because it doesn't have to be 0 to some t of f of t dt, then f prime of x, that should be an x, sorry, this should be an x, people, is equal to, oh, I picked the wrong, let me actually write a formula. I'll say root t, say it's that, do an actual example. Then the derivative cancels the integral essentially, and you get root of x. Does that make sense? Do you remember learning that? Where basically if you do the derivative of a function that's defined by an integral, it cancels the integral, and this variable goes in for t.
So basically, whatever's on the top there, we don't have to do anything special.
There is one caveat. So if you have something that looks like this, integral from 2 to, I'll just say x squared. Actually, we'll say x squared of t plus 4. Then f prime of x squared goes in for t. But then what do you have to remember? You have to remember chain rule. And you say you're doing the derivative, which cancels the integral, but chain rule says you have to do the inside derivative. You have to do what's the derivative of x squared? 2x. So you multiply that by 2x. And that's your answer. So if it's not x, if it's just x, it just goes in. If it's anything else, you have to multiply by the derivative.
What if it's like 5x?
Then it would just be multiplied by 5.
Okay.
I've got actually
That was so much more simpler.
There's also the average value.
Average value. Is he going to put an average value question on?
Maybe. He gave us the formula, so.
Average value of a function?
Yeah. Or
Okay, so we'll go over that. All right, so average value. So the average value of a function, f average, is equal to 1 over b minus a times the integral a to b of f of x dx. He will give you that formula. I don't want to speak for him, but he seems like you don't have to memorize any formulas, right? So, okay, let's just do a quick practice average value function, then we can move on to integration. So here's an average value question. Determine the average value of f of x is equal to 3x squared minus 2x on the interval 1 to 4.
Whoa. Eminem can't even go that fast. Though. Like she's spitting bars. I'm gonna put a beat behind this thing. It's impressive.
All right. Basically, just plug it into the formula. These are your A's and B's. A, B. So you just go f av is 1 over b minus a, 4 minus 1, times the integral from a, 1 to 4, of our function. And then you just do it. So I'm going to freeze it, and we're going to see if we end up in the same spot.
You have the F and B F of anything.
Yeah.
What's the formula for that one?
F of b minus f of a. And you can just leave your answer as a fraction.
Oh shit. We over it over there. He's just trying to mess with us.
You ready?
How'd you get a fraction?
Yeah, I was gonna say, you need
Yeah, if you go fraction, there's a problem here.
Over 1, maybe. Like Miles was saying.
What?
You can divide 48 by 3.
But you can still leave it as a fraction. Still a fraction. Okay, 48 over 3, or if you prefer non-fractions and whole numbers. 16, I guess, is okay. Or 16 over 1. Fraction.
So we don't chain rule. The only reason you put brackets there is because you're putting a dx multiplying all that, right?
Chain rule.
Well, like because you put like 3x squared minus 2x in brackets, but there's no chain rule there at all because it's just
Chain rules derivatives.
sweet. Oh,
These
this
are
is
anti-derivatives.
Yeah.
Don't even
Don't do chain
bring
rule,
up chain rule.
right? We're not doing the fundamental theorem thing, right? We're not doing.
Yeah, you know what? I thought you were going to try to mess with this a little bit.
If that was all
No.
Then we'd have to use substitution.
Then you would have to use substitute or expand it. Yes. Okay, we're gonna do U sub in a sec. Okay, that's average value. Here's some questions if you want practice for average value questions in the book 288, 51 to 55. That's practice on average value questions. Okay. Do you want U sub or do you want it? Maybe we should do a limit definition, the rectangle stuff, and then we can just do U sub for the rest of the block.
U sub's easy.
All right. The summation stuff. Because he said he was going to give you one of these things, right? Nobody likes this stuff. All right. We got to pick a straightforward one here. Okay, summations. Let's do. Okay, what's the formula using rectangles for the sum to get the area under a curve? Does anybody remember the formula? It's a limit, right?
Limit as n approaches infinity.
The limit as n goes to infinity of
The summation
the summation
of I equals 1. N equals 1.
n equals 1 to infinity, essentially, or n, but we'll say n.
A plus I delta x.
What's that?
I plus 1.
No.
Oh,
Is it I is equal to 1?
yeah.
Yeah, because the number of rectangles is n, so it's i's go to 1. Sorry, thank you. Yeah, I goes to 1 to n, that's why. Duh, thank you. 1 to m, f of c delta x, where this is the height and that's the width, correct?
Yep.
And remember c, if you do the right side, which I would say I always use the right side when I'm doing it. It's ai plus delta x. I don't know. And if this is the right side, and the left side is a minus 1 I plus delta x. I always use right, but it is your choice. Is it I delta x?
A plus I minus 1.
A plus I. Jeez, I can't even remember. I'm trying to do this off of memory.
Yeah. A plus bracket
I delta x. Thank you.
I minus 1 delta x.
Bro.
Times delta x.
Sorry.
What? King.
You just call me
Okay,
king.
That's correct. Yeah. Like looking at my notes.
There we go.
There we go.
And in fact, I have my notes
Now,
right in front of
what's
me. So if I
midpoint?
looked at them, that would probably help.
What's midpoint?
Okay. All right. All right. So what function? Let's do an easy function. We'll do x squared because it's straightforward. Area under y is equal to x squared from, make it easy, from x equals 0 to 2. So essentially, here's a graph of y is equal to x squared. We want to know the area from 0 to 2. Yeah. So this is A and that is B. Okay. Are we ready? Here we go. So first of all, what does delta x mean? What's the formula for delta x?
B minus A all over
N. The number.
Yeah. It's a difference between the endpoints divided by the number of rectangles that you're going to use. That's what n is. So b minus a is 2 minus 0, so it becomes... Yeah, so you don't write 0 though. Because yes, delta x does go to 0, but you don't do that yet. So it's 2 over n. We're going to use right endpoint. So our c value is a plus I delta x. Our a value is 0, so that makes our life easier. I times delta x, which we just said was 2 over n. So it's I times 2 over n. I'm going to write 2i over n because that makes a little more sense to me. All right, are we good? Okay. Then this and this go into our formula. So the only thing that's annoying about this is writing the limit every time. The limit as n goes to infinity. I is equal to 1 to n of f of our c value is 2i over n. Delta x is 2 over n. All right. Now what?
Put it in the
So we have
equation.
to use f of x,
Yeah. So this says f of a something, right?
plug that in.
So the something, the 2i over n, goes into our function. So we get
Right?
I know. 2i over n all squared times 2 over n. All right. Now it's just algebra. Can you do the algebra?
No.
Want me to take you through it?
No.
I'll do the next. Well, what's the next step right now?
What goes to infinity?
Put the square in.
Yeah, you got to square the 2i over n.
4i squared over n squared.
4i squared over n squared times 2 over n. So we can actually clean that up. 8i squared over n cubed.
Now we pull out the 8 over n.
Yes. Anything that is not an I, pull it out.
Oh, wait, what's this?
Okay. All right, we ready?
Yep.
Now, this bit is the formulas that we did in class that day that you don't need to memorize. He will give them to you. All right. So the sum of I squared, anybody remember it?
N
Mm-hmm.
times n plus 1
Do you
times.
have to write the limit again?
Yeah, because we haven't actually done the limit yet.
Oh, yeah.
Oh, what is it? N plus 1, 2n plus 1 over 6. Because that is just getting rid of the summation bit, this green bit. We still need to do the limit. I'm going to clean this up a little bit before I do that. So I'm going to do a couple steps in one step here. This n here will cancel one of those n's. Does everybody agree with that?
Yeah.
Okay. And the 8, I'll just leave it as 8 over 6. I'm going to pull out the 6. So I'm going to get the limit as n goes to infinity of 8 over 6, which is 4 over 3? No.
8 over 6.
Yeah.
4 over 3.
4 over 3.
Yeah.
And that n will cancel those. That would be n squared. So the top is going to be n plus 1, 2n plus 1 over n squared. Correcto?
Sure.
That makes sense what I just did?
Yeah, you just kind of combine it.
Yeah.
Yes.
Okay, now I'm going to expand the numerator. All right, that's just foiling. I'm just going to give you what the answer is, or what it expands to.
I'm gonna try to limit every single time.
I know that's until you actually do the limit. Yes.
Can I say or the limit of n as it approaches infinity is equal to u, and then just write u every time instead?
You're going to have to ask him that.
Because I think substitute.
I'm not marking your test. Sorry.
You should.
Why?
You both mark. Actually, I think he marks nicer than you do.
I know.
Crazy.
Straight up.
Okay, so you have that. That's the expansion of the numerator.
Yep.
Okay.
Literally see-
That was
If you have a single denominator, it goes to everything in the numerator, right? So then you rewrite it like this. It's a lot of steps.
This is an entire page, actually.
I know.
Can you just go faster?
Well, I'm writing all the steps out. Like, you could probably combine some of these. Like, yeah, you could combine this step with the next step. Because my next step here is to simplify this whole thing, right? This bit. I'm just showing you step by step so you can see how you actually get the answer.
How do we pull the? We kind of just pulled the n squared. It was over the 8. We kind of just pulled it over to the equation on the right.
Because you're multiplying, right? So it doesn't, you can kind of move it back and forth. So then that cancels that. That cancels one of those. We're almost done. Of 2 plus 3 over n plus 2 over n squared. Okay. Now we can do the limit.
Yes.
Yeah, that's the answer I was looking for. Okay. So when you put infinity in, what do these two do? They go to 0, right? Because it's a constant divided by infinity. So that goes to 0. That goes to 0. You're left with 2 times 4 over 3, which is
8 over 3. For 2 and whatever. 2 and 2/3.
we're done. Even JM doesn't like that stuff. All right, so we get 8 over 3. What is the actual answer? If you did the actual answer, don't write this down. Like if you did it the normal way where everybody would do it instead of this way, and you did the antiderivative from 0 to 2,
Why do you have to do it that way?
because he's going to ask you to do it that way. It's like the limit definition of a derivative. You have to do it once, and then you never do it again. It's so you understand where the one on the right or on the left comes from. So then I put in 2 cubed over 3 minus 0. 2 cubed is 8.
So that's how we can check our answer.
Yeah.
My calculator says 2 and 2/3, actually.
Your calculator is
No way.
wrong. So this is how you can check your answer on a test. You can actually just do the integral. Okay? But, well, if I zoom out, there you go. This amount of work,
But 8
Or
over
that.
3 and
okay?
it's actually trash.
You will only have one question, and I doubt there'll be a question on the final on this kind of summation stuff, because they do it on the unit test and you don't. But I would, again, check with him to find out if he's going to put one on the final. All right? But, okay, so do we all feel okay with that?
Yeah.
I know we don't like it, but it is what it is. If you were looking for questions on that specific stuff, let me make sure I got the right page here. I think it's 264.
What are we doing?
No, I'm not going to give you a question. I'm just going to tell you where you can find some questions to do this. Yeah. Page 264, if you wanted questions on this particular type of stuff, numbers 45 and 47 would be helpful. Okay? If you wanted that. All right.
Hang on.
We've done average value. We've done that. We did differentials. We got U sub to do now, right?
You don't have any school credit.
Okay.
Great realization. Thank
U
you.
substitution. Here we go. Okay. All right, let's start with, well,
I use them like
if I gave you this question, if I just give you that and said, do it, integrate that, what do?
You
You just do your derivative.
Yeah, you just integrate it, right? It's not a U sub. If you can just integrate. The only reason you use U substitution is because you can't just integrate. You're trying to change the form, right? So this, you're not even doing anything. You're just doing the power rule. So it's x cubed over 3 plus x squared plus 3x. Tack on a plus c, and you're done. You walk away. All right. But if I give you something like this, you can't just do that, right? You got cosines and sines in the function. That turns into a nightmare. So you have to do U substitution. 99% of the time, what is U going to be?
Whatever's on top, so it
The
The
bottom.
bottom one is in the radical.
It's going to be whatever's in the radical or if it's brackets to a power. It's not all the time, but the vast majority, that should be your go-to to try.
The one that's the funny.
Sure. Let's go with that. So we go U is equal to sine x. You don't include the root, or if it's to the power of 5 or whatever, you don't include that. It's what's inside of it. What's the derivative of sine? So du over dx is equal to cos of x. He solves for dx, right? That's how he does his stuff?
Yeah.
Okay. So you solve for it, and then you plug it all back in, except do we like roots?
No.
No, we do not.
Like 1/2.
We like 1/2. So we rewrite this as cos of x over u to the power of a half, and then dx is du over cos of x, and the cosines go bye-bye. So do I want the 1/2 u on the bottom, or the u to the half on the bottom?
No.
No, we're going to flip that up. Now that is just like this one. We can use the power rule. Add 1 to it and divide by the new exponent. So we get u to the power of a half. Divide by a half means you're multiplying by 2. Plus c. The only other thing you have to do is
Put U back in.
put u back in.
Substitute.
You leave it like that. And you could write 2 root sine of x plus c. It's your choice. That's it. How could you check your work?
Take the derivative.
Take the derivative.
Or take the derivative.
If you took the derivative of this, you should get back the original function.
And then 2 times sine x is the power rule.
Well, yeah, like you drop the 1/2 down, which would cross out the 2.
Oh, right.
Take 1 away, so that gives you negative power of a half, which is the square root of sine.
And then the
Derivative of sine is
what's the derivative of cos is
negative sine. Yeah.
Well, like,
Okay.
Maybe you're
Do we feel okay with that?
Yeah.
Okay. All right. No. We gotta do a couple of trickier ones. Oh yeah. Well, not for. I will. You'll see in a sec.
No.
You hold on. Hold your horses. Okay. We gotta do a definite.
Yeah.
Integral. I'm just gonna make one up, so probably not gonna be the nicest numbers.
72.
Let's do.
Real big. Come on. And then fish, right? Stops it.
What are some numbers?
42.
No, we're not doing 42.
14 and 3.
2 and
9, 7,
7.
4,
2 and 7?
2
4,
and 7. 2 and 7 is 4.
2 and 7?
2 and 4.
Those are hard numbers. 2 and 2
As
and 3.
what?
Let's
Oh,
go
for-
negative 1.
To 2.
Okay, to 2.
We're weak. 47.
47 would not have been
I know,
fun.
it's so much fun. You're just popping in your calculator. Who cares?
Okay.
Really, 2 negative 1s.
Stop. That's outside our domain. Thank you.
Big
Well, let's make it easy. We'll do 1 then.
Negative
You gotta stop changing systems.
Yeah.
It's not that hard for me. I just hit a little button on my pen and just erase. Okay. What's u going to be?
X squared plus 2x.
X squared plus 2x.
One that looks like the derivative becomes that stuff.
Exactly.
Oh, we can yank a little 2 out of this too.
I see what you're doing.
Messing you up.
I know.
It's like the quiz.
Just like the quiz.
And then we solve for
We
dx.
did that online quiz. We forgot to do it, and it's not. Do you have-
That's a question for JM. Not me.
I don't even know if it was wrong.
Okay, what else do you have to do because it's a definite integral?
So you have to evaluate it on the thing at the end, but like you have to do it now.
So you have a choice. Remember, you can do the whole thing,
Oh, you can make
or
it-
you can change the interval, right? To change it to your u values. So that's the way I'm going to do it here. You don't have to. So when x is equal to 1, if I put that into this equation, what does u equal?
3.
U is equal to 3. Does that make sense?
Yeah.
Okay. Then when x is equal to 2, u is equal to 4 plus 4 is 8. So now my integral becomes, once you sub in everything, so when you get the integral from 3 to 8, u to the power of a half times du. I'm going to factor out a 2. Does everybody see why I factored out a 2?
So
Hang on.
oh, dude.
Oh,
Because then the x plus 1s will cancel.
I see.
It's just right there. But you're going to see I can, so this is my integral that I'm going to evaluate. 3 over 8, I can pull out the 1/2. That's my integral that I'm evaluating. Which is that's a pretty straightforward. We took a gong show integral and turned it into something that's pretty simple. So we add 1s, we get 3/2, divide by that, so it's like multiplying by 2/3, evaluating it from 3 to 8.
You're not going to plus C?
You don't have to do plus c's when it's a definite, right? Because the c's would cancel.
How do you know it's definite again?
Definite means it has numbers on the top. This 3 and the 8 means it's definite.
Or like,
Indefinite is the one up here that didn't have anything. So we have to put a plus C. All right, now we just plug in. Did anybody do it? I don't know what the answer.
2.905.
Not a
Did people get 2.905?
8% squared.
not a chance.
oh, you just. You didn't, oh, we didn't have to replace the U with the.
No, that's why you can do it that way, right?
No. Yeah.
If you want to replace the u, you don't want to use the 3 and the 8, then at this stage right there, you're going to be evaluating the integral 1/2 to, what was u? X squared plus 2x to the 3/2 over 3,
Maybe I calculated it.
evaluated from 1 to 2. Did people get 2.905?
No,
I just did it again. I got it different.
I got 5.810.
Yeah. Yeah.
5.8?
Yes.
Sorry for people watching the video that were not in class. That was Eamon.
Ouch.
Give him a last name and a.
No, I'm not going to put his last name.
Here, I'll get a Snapchat for you
I'm
as
in
well.
a university where you're watching this video so I can understand what a function is.
That's what people did this year. I got a lot of emails. All right.
Sucks to be in the office. I guess.
Are we okay with that? That's kind of the chapter. Do you feel okay?
I feel
Chapter
fine.
4 was
That's
not
just a
big.
chapter.
You have to do U substitution with definite and indefinite. Average value, which we did. You're going to have a summation question. And the second fundamental theorem, which is the derivative of an integral, which then that sounds back in.
Yeah.
If I forget stuff.
The second fundamental theorem. You want a hard one?
Not a hard or
Can you give us?
I don't understand that.
Hard one. Let's do a hard one.
semi-difficult one that we can-
Semi-difficult.
Also, any
Oh yeah, I'm gonna show you it. All right, semi-difficult, semi-difficult, semi.
Oh,
Is it a lot difficult?
Here we go.
he clapped. It's not semi.
All right. Yeah, you'll like this one.
Yes.
Oh yeah, I really like this. Thank you so much.
What the fuck?
Hey, this is going on YouTube.
Okay.
Who would ever do this?
Fine. Nobody. It's just in a calculus class.
Why are we learning it?
Well, some functions are defined by the area under the curve. And I think if you watched my video on the natural log, it's actually, I don't know if anybody watched the video.
I watched it.
The derivative, the natural log function is defined as,
One of
yeah, it's the area under the curve from 1 to x of 1 over t, right? dt. Why is it not writing? So if you look at the curve of 1 over t, 1, that's x. It's that area. So it's a sliding thing. So when you say natural log of 3, it's the, you'll probably have something like this from 1 to 3. So sometimes you have to do the derivative and understand it. It's just sort of the first fundamental theorem is what you use all the time. This, if you go on, it's probably going to become more and more important, but you get the sort of standard question. How do you do this? You actually don't need to know what the antiderivative of natural log of t is to do this question, right?
Is a question like that going to show up on a test?
It could. This is a question from last year
On the test.
on a quiz. So, but you don't. What happens when you do the derivative of an integral?
It gives you the function.
Yeah, it just cancels each other out, right? So the only thing you have to remember, why is this? The integral goes away. What's here goes in for t. Why can't you write? So I get the natural log of all this junk. Oh my gosh. Sine
Looks like a fancy button's back by a minute.
x. I think the battery's dying.
Do you want the battery out of my pen?
Sure. If you want to give it to me.
The touch screen on my laptop broke, so I got to give it to Best Buy.
Oh,
So I can't use my pen.
that's not good.
Yeah.
And then the only thing you have to remember is you have to do the derivative. You have to use chain rule. So we need to do the derivative of this. What's the derivative of sine? So I get cos. Oh my gosh.
Cos x squared
X.
times 2x minus 2x. Oh, but just minus 2.
Oh. Thank you.
Isn't that like power where you have like the
TA coming in
the
clutch.
prime-
Yeah, see, I finally do something in this
Thank you.
I'm gonna be real confused when my pen doesn't work in a couple months.
Come on. Okay. Oh,
Maybe it's
X.
10.
Oh, there we go. So cos of x squared minus 2x times the inside of this, which is
2x minus 2.
That's our answer. Or what?
that.
That's it.
That's your answer.
I mean, that's it. What did you do?
So we just plug in.
So, okay.
P value.
If you get a function that is defined as an integral and they ask you for f prime of that function,
Okay.
when you take the derivative of this, it essentially cancels that. Did he show you why this works?
Yes, but it was really confusing.
Yeah, I tried to do that.
Okay, look, let's do it the long way.
No,
And you'll see, no, you only have to do it the short this way. And I think he even said, oh, you'll just do it this way. But just so you can see, it actually is the truth. I gotta find it in my notes here.
I believe you.
You believe me?
So you just plug in whatever is the top bound.
And you multiply by the derivative of that. I can't find it. Okay, so for example, if I had this, if I had f of x is defined as the integral from 0 to x squared of t. We'll just make it straightforward, t, okay? And I do the antiderivative of that. I go, okay, well that's t to the power of 2 over 2 evaluated from 0 to x squared. I put in the x squared and I get x
Like, aren't those?
yeah, x to the power x squared to the power of 2 over 2. The 0 is going to go away, like minus 0. So I just leave it like that, which is just x to the power of 4. Does everybody agree with that? Okay. And then I do the derivative of that. Okay. So that's f of x. So if I said, okay, what's f primed? Well, what's the derivative of this? You drop the 4 down. Why isn't this working?
I think it's just the pen at this point.
Oh, you know what I forgot? Oh, no, we're good. Yeah.
Oh, that works.
I get 4x cubed over 2, which is just 2x cubed, right?
Yep.
Yeah, okay. All right, now, what if I just did this? What we were doing is we took this
Plug in.
and put it in, and I get x squared.
And then we put it into dt, so you have to take the derivative.
So you multiply by the derivative of that, which is 2x cubed.
That
Okay. So when you do the derivative of an integral, those are opposing processes, right? So you essentially cancel that. So you just sub in your upper limit, and the only trick is multiply by whatever the derivative of that upper limit is. You do it even when it's an x, but the derivative of x is just 1, so you never really see that.
The bottom is always going to be zero.
For what you're going to see, it's going to be a constant.
Okay.
And then so the derivative of any constant is 0, right? Because if I had this as 1 and I got 1 over 2 over here, when you do the derivative of that constant, it just goes to 0 anyway.
But it was like x to x squared.
If it's x to x, it's a little trickier, but you don't have to worry about that. Okay? For ask him.
Okay.
I've never put that on a test of mine. I've only ever done a constant to a variable.
If it was x to x squared, though, would you just do like a f of b minus f of a kind of thing, where you just
Yeah, essentially. So, but you have to remember chain rule of that, because if you made it like x squared on the bottom and x cubed, you can make them as complex as you want, but the purpose of this is I'm 99% sure you're just going to see a constant to some variable. Okay, so the constant you don't have to worry about. All right. Okay. That's pretty much 10 minutes left. All right. So in the classroom,